141, 142, yes?
Yes.
Going to it.
It's gonna be a what do you call it? It's super season.
All right, anything 1 through 8 you want to take a look at? 1 through 8.
Number 8.
Number 8. Is that all right? Add those together. That looks like 6x, and then let's add 12 over here. So that cancels.
You can take 2 up.
I could have, but then I can divide everything by 6, so I find that x is equal to 2. Anything else 1 through 8? 6. This one's a quadratic, yes? So I have to do my magic number, which is negative 54. Is that right?
6 times 9.
And then 154, 2 and 27, 3 and 18. 4 don't work, 5 don't work. What is 6 and what? 9. 6 and 9 works. Which one's negative? 9. Okay. X squared minus 9x plus 6x minus 54. What do I have in common there? X. That's x minus 9. What do I have in common here? 6. All right. X minus 9 and x plus 6. Am I done at this point? No, I need to solve it. So I'm going to put x minus 9 equals 0. So x equals 9. X plus 6 equals 0. So x equals negative 6. So we're good on the front side? Yo.
So if you have one side or parentheses, would you count it wrong since they're not?
If you left it here like this,
Yeah.
I want you to take it to that. So this would probably be a 3-point problem. If you left it like this, you'd probably miss 1 point. All right, backside. 15. That one's hard. 15 is raised to the 3rd power. So at this point, we should, bless you. Thank you. All right, so let's move the 100 over so I get this. Is that all right so far? Okay. We have a greatest common factor of x. All right, so x is equal to 0. This is one of my answers. Okay?
It's 100.
Oh, it's 100. Thank you. And then let's do the factors. My magic number is negative 100. I have alternating signs. 1 and 100, 2 and 50, 3, 4, 4 and 25, and 5 and 20, and 10 and 10. Which ones work? None? I think 4 and 25 works, but I might be wrong. All right, so x squared minus 25x plus 4x minus 100. What do I have in common there? X minus 25. What do I have in common on here? 4. Good. X minus 25. Okay, so then I'm going to get x minus 25 and x plus 4. Set each of those equal to 0, so I get x equals positive 25 and x is equal to negative 4. What are my 3 answers? 0, 25, and negative 4. Cool. It's raised to the 3rd power, so you could have up to 3 answers. Anything else up through number 16? 13, yeah. Number 13, 3x minus 2, x minus 1 equals 4x plus 8. All right, make sure you distribute the negative to both of those first. Is that okay so far? All right. Combine those like terms. 3x minus 2x is just x. X plus 2 equals 4x plus 8. And let's start solving it. Let's see. Maybe subtract 2 from both sides. So x squared equals, oh, I don't know why I put x squared, sorry. X equals 4x plus 8, or plus 6, excuse me, minus 4x from both sides.
Negative 3x.
Yeah, negative 3x equals 6. Divide each side by negative 3.
Negative
So it's negative 2. Sweet. So the big error on that one would take place right here. You got to make sure this negative goes to both. Okay? That's where students would make an error a lot of times. Any other questions from the homework? 10? Number 10 appears to have a greatest common factor of what? 2. Right. So if you wanted to, on this one, because you're solving it, you can divide everything by 2. Those cancel. X squared plus 20x plus 50, or excuse me, 100 equals 0. Just do it quick. x10, x10. So x equals negative 10, and x equals negative 10. Hey, quick question. If I get the exact same answer, what did this parabola do? If I graphed it? Bounced off the x-axis. So the vertex actually on this one took place at negative 10, 0. Okay, it's called the double root. If it happened twice, it just bounces off the x-axis. Okay? We good?
Could you also do number 14?
Yeah, number 14. So it's kind of weird. We could try and solve it, but we have this squared term. So what happens if I do this? That work?
You can take out 2.
I could take out a 2.
And then you could do like
unsquare.
difference of 2 squares.
I don't know if it's different to do squares though.
7 squared minus 18.
What's 36 over 2 though?
18 is
18. 18 is not a perfect square, is it?
Can you do it with 36?
Yeah. So I thought this would have worked out a little nicer. So let's take this straight over this way. Let's adjust this way. What would I have done?
Out of 24.
I added 24 to both sides. And let's start on doing this. Let's see. If I go this and this, so I have m squared equals 18. So yeah, if I unsquare it, so take the square root of both sides, one thing you have to recognize is a square root can have a positive and a negative component. So that right there, if you got to that answer, you're probably fine. I probably wouldn't give you one like this on the quiz. Other things that you probably should recognize, so if you got to here, you're like an A++ student. So I can break 18 down to 9 times 2. Square root of 9 is 3. If you got to this point, you're like ready for calculus. But if you got to here, I'd take that. But you probably won't see a problem like that on the test or quiz. All right, if you would, make sure your name is on that page. Pass it on forward, please. It's easier that way.
We have no homework today?
Huh? Oh, I got some notes we're going to do here in a sec.
But it says no homework on the board.
That's on the other algebra class.
Oh yeah, no, I knew that.
Yeah. I'm the Mr. S top of the one.
Oh yeah, no, I knew that. No.
Or you were talking about the other class.
No, I was talking about the other class. No homework.
You always have homework. We never have homework when we take tests.
Yeah,
the normal days work every day. Oh, thanks. May the
It's your birthday.
May the fourth bit.
Ben?
May the fourth.
It's her birthday.
It's your birthday? Woo, cupcakes.
Of course.
Cupcakes.
Ice cream.
I like both.
Happy birthday.
All right. Let's.
Actually, let's just go. We need to watch Star Wars.
Yeah, we'll get right on it.
Wait,
Episode
can we watch
3.
like a movie?
Wait.
No.
Sometime.
Episode 3.
Alright, quadratic equations number 2, solving special cases. So special cases in this case would probably be difference of two squares, things like that. So let's take a look at solving some of these special cases. First one. Oh, first we want to multiply these all out. So let's see. X squared plus 4x minus x squared plus 4x minus 4x minus 16. What cancels? Those are gone, right? So I get x squared minus 16. So that's the difference of two squares. Okay, that's how it would factor out. Next one, I would get 9x squared plus 15x minus 15x minus 25. What happens there? Cancel out. I get 9x squared minus 25. Again, difference of two squares. Take a look. Same binomials, one sign different, right? Oh, let's multiply a times b, a plus b, a minus b. So I get a squared minus ab plus ab minus b squared. What happens there? Cancel out. So I get a squared minus b squared. So that's by definition difference of two squares. Okay? But then, as we roll down here, how many x minus 4s am I multiplying together? 2. So I have x minus 4 and x minus 4. If I multiply those out, I get x squared minus 4x minus 4x plus 16. Do my middle terms cancel out? No. So then I get x squared minus 8x plus 16.
So if there's anything like this, so would it just be x squared minus that number plus or minus that number?
Could be. Could be. All right, this one, x squared minus 6x plus 36. So I get x squared. Those don't cancel, do they? So I get that. And then last one, let's see, 4x squared plus 6x plus 6x plus 9. Again, those don't cancel. But realize it's the exact same binomial, not alternating signs. What do you think? So sometimes you might have the exact same binomials separated by one number or by sign, and things fall out, so it becomes two terms. So that's the difference of two squares. But sometimes you don't. Sometimes you get the exact same binomial multiplied by the exact same binomial, which is becomes a perfect square binomial. And a perfect square binomial, when you solve it, actually is one of those cases if you were to graph the parabola, it would just bounce off the x-axis. You'd have a double root. May I move forward? All right, so we had two special cases, difference of two squares and perfect square trinomials. So Ram, to answer your question, will you always have minus plus? No, look at this one. Cool? But you could have the minus minus, and that's going to create your minus plus. Like you discovered, which is great. Is that all right? So difference of two squares, your answer is two perfect squares, and when you break them apart, they separate into two things. All right. First problem. Does it appear to be the difference of two squares? Yes. So this will break down to x plus 6 and x minus 6. And then it's equal to 0, so we want to solve each. Agreed?
Negative 6.
And positive 6.
So x equals negative 6. X is equal to positive 6. Okay? Yep. Oh, you want x minus 6 first and x. All right, this next one, 25x squared minus 49y squared.
Equals 49.
Yeah, it's equal to that. So I'm going to subtract this. I'm going to bring it over. So it appears that this is that. Do you agree? And 25x squared, is that a perfect square? What about 49y squared? Is that a perfect square? Yep. And this is the difference of two squares. We have a minus sign. So I have 5x plus 7y and 5x minus 7y. Good. Now this is kind of a goofy one. How do we set this one up equal to 0? I get 5x plus 7y equals 0. What?
Make it linear.
5x minus 7y equals 0. So this is probably not one we would try and solve. So I think they might have made an error when they did that. Because you would subtract 7y and then divide. So technically if you're solving for x, this would come out to be negative 7/5 y. And this would come out to positive 7/5 y.
Couldn't you make it like a linear equation though?
You have two variables that are stuck in there. Okay, moving on. Solving that. So things that I would look on here. That's a perfect square. Agree? Because 7 times 7. So I'm curious. Our magic number is 49. In order to get a positive 49, and this is negative, both sides need to be negative. So if we just use the 7 and the 7, is negative 7 plus negative 7 negative 14? It is. What do you think? And then if I factor out an x here, and what should I factor out here? A negative 7. That's going to lead me to x minus 7, x minus 7. That's equal to 0. So then I get x minus 7 equals 0, and x minus 7 equals 0. So x equals 7, and x equals 7. If I were to have graphed this as a parabola, what do you think's happening? Does it cross the x-axis twice? No, it bounces off of it. And so this is where the vertex will take place. All right. What do you think about that last one? It says, oh, we have a hint. So we have a greatest common factor. So being it's equal to 0, I could try and factor out the 6, which is fine. Or what I could do is being it's equal to 0, I'm not trying to break it into factors at this point. I could divide all terms by 6. What I do on one side of the equal sign, I have to do the other side. So this is x squared plus 10x plus, oh shoot, how many times does 6 go into 150? Any idea? I know it goes into 12 twice.
25? Yeah,
25, okay. And that's equal to 0 because 0 divided by 6, right? All right. I'm curious. This is a perfect square, kind of like that. I wonder if this factors to x plus 5x plus 5. Let's just see. Let's just see if we're right without doing our factoring. So that would be x squared plus 5x plus 5x. That would give me 10x plus 25. Ooh. Does it work? So sometimes you can see a quick shortcut if you recognize that you have a perfect square trinomial. So then you have x plus 5 equals 0, and x plus 5 equals 0. So x is equal to negative 5, and x is equal to negative 5. So again, what's taking place? If you had graphed this, what would be taking place with the parabola? It bounces off. So the vertex is happening right on the x-axis. What do you think? Was this okay? All right, your assignment. So this was last night, so let's not worry about that. So this is going to be worksheet. It's going to be pages 143 and 144. And I want to give you guys and girls the opportunity to start working on that now. If you happen to get it done, then sweet, right? So go ahead and try working on that now. You have 20 plus minutes left, so this is not pack up and stand by the door time. Cool?